Alright, so I've been asked by some more people to do some more math review. Here are some kind of hard problems that someone referred to me. This is on trigonometric identities. This is for solving trigonometric identities. This first problem is. So it is sine of 2x minus tangent x equals cosine 4x minus sine 4x all over cotangent x. Don't forget, guys, your x's. Alright, so what I'm going to do is I'm going to translate this down to here. Cosine 4x minus sine 4x over cosine, or cotangent. So I'm solving this side because it looks less complicated, or more complicated than this side. So cosine 4x minus sine of 4x is a difference of squares. So this could be equivalent to cosine squared x minus sine squared x. Oh yeah, and then multiplied by cosine squared x plus sine squared x. So I'm going to put that up there. Now, if you look at it that way, you have cosine squared x minus sine squared x times cosine squared x plus sine squared x. Now, cosine plus sine squared x is equivalent to 1, so I'm going to erase all this and multiply whatever this is by 1. Oh, forgot it's all over cotangent. Then cosine squared x minus sine squared x is equivalent to cosine of 2 theta, or in this case, I'm going to cross this out, and it's equivalent to cosine of 2 times x. This is not cosine squared, it's cosine 2x. That might be easier if you look at it like that. Now 1 times cosine 2x is cosine 2x, right? So I'm just going to erase that. Okay. So now we have cosine of 2x over cotangent x is equivalent to sine 2x minus tangent x. Now, if you look at your blue sheet, cosine of 2x could be one of three things. It could be cosine 2 squared x minus sine squared x, 1 minus 2 sine squared theta, or 2 cosine minus 1. So I'm going to go with the 2 cosine minus 1. 2 cosine x, cosine squared x minus 1. So get rid of that and put this all over cotangent. So now we're gonna make a new page, make it clear. Theta equals 2 cosine squared x minus 1 all over cotangent x. So now I'm going to separate these two terms because there's a minus sign in the middle. So equals 2 cosine squared x over cotangent x minus 1 over cotangent x. Now this right here simplifies straight into tangent x, so we have that part down. And then this over here, I'm going to do some little work on that over here. 2 cosine squared x over cosine x over sine x, because that's what cotangent is. Now technically when you're dividing by fraction, you want to keep change. So what we're going to do is we're going to do some more work on this. 2 cosine squared x over 1 multiplied by sine over cosine x, because we're dividing by this, so we're going to flip it and multiply. Now this is going to become, this will end up being theta equals 2 cosine squared x times sine x over cosine x minus tangent x. And now we're gonna get rid of the squared and get rid of the denominator. So if I new tab, so theta is equivalent to 2 cosine x times sine x minus tangent of x. Now 2 cosine of x could also be, oh, so this right here, 2 cosine x times sine x is equivalent to 2 times sine times cosine x, which is technically this equation right here is equivalent to sine of 2x. So that's what we're going to substitute in for. And this and when we do that, sine of 2x minus tangent x, we get exactly what the original equation was, which was sine of 2x minus tangent x. Alright, so some other things that I've gotten asked for were some double angle identities and some half angle identities. This is a very long worksheet, so I'm going to choose a problem or two that I think is kind of hard. So I'm going to start with the double angle identities first. I'm just going to do 1 or 2 problems, so I'll do number 1 and number 3 from double angle identities, so this is going to be number 1. So if cosine of theta is equivalent to 8 over 17, and theta, oh, that's an 8, and 3 pi over 2 is less than theta is less than 2 pi. And it asks for sine of 2 theta. So first off, we have to find out what sine of 2 theta is. So sine of 2 theta is equivalent to 2 sine theta times cosine theta. Now, to find out what sine theta is, we first have to use this measurement that was given to us. So 817, which means the adjacent value, if theta is here, is 8, and this is 17. Now, so if we plug this into a calculator, let me go, you know what, I'm gonna have to do this on my browser. Calculator, don't know how to spell calculator, so it is 17 squared minus 8 squared, which is 64, square root of that, 225, would be 15. So this side is going to be 15. So sine is equal to 15 over 17. So now we can plug that into here. So I'm going to do this is equivalent to 2 times 15 over 17 times 8 over 17, because that is cosine over here, and then sine is equivalent to opposite over hypotenuse. So 15, which is the opposite, over the hypotenuse of 17. Now if we multiply this all together, it'll be 30 over 17 times 8 over 17. If I do this with my handy dandy calculator, the top comes out to 240 over 17 squared, 289. And I don't think you can reduce that. And so now this is going to be our value, but this is not our answer. This is not our answer, so I'm going to erase, kind of like scribble out the box. But this is going to be the value of what sine of 2 theta is equivalent to, because that's what we're finding, sine of 2 theta. But it is between 3 pi and 2 pi. So if we draw that out in a unit circle, this is 0, this is pi over 2, this is 3 pi over 2. If it's between 3 pi and 2 pi, it would be in here. and sine is negative here. So the sine of 2 theta is going to be equivalent to negative 240 over 289 because this fraction cannot be reduced. Now, that is the answer for this, and the way I got this negative once again is because you have to look at the restraints, and this is between here, which means this quadrant, and sine is negative in this quadrant. Now I'm going to be doing number 3. So if tangent of theta equals root 7, negative root 7 over 5, and theta is between pi over 2 and pi, find cosine 2 theta. So cosine of 2 theta is equivalent to... Oh, actually, first we're going to take these measurements and we're going to make them into a... we're going to take this measurement and we're going to make them into a triangle. So tangent is equal to... what is it? Opposite over adjacent. So if theta is here, we're going to do root 7 over negative 5. Okay? So this would be 7. If we square this, because a squared plus b squared equals c squared, so 25 plus 7 equals 32. So root 32, which can be reduced to 4 root 2. We're going to get that out of here. It's 4 root 2. Okay? So now if we do cosine squared of e is equal... cosine... Oh my god. Cosine of 2 theta is equivalent to 1 minus sine 2 sine squared. So sine squared theta we know now off of this is root 7. So sine theta is equivalent to root 7 over 4 root 2. Now if we do this more, it'll be root 14 over 4 over 8, and root 14 cannot be reduced, so this will stay as root 14 over 8. If we plug that in, if we plug this value into here, we will get is equivalent to 1 minus 2 times root 14 over 8 squared. Now if we do this and we square this, it'll be 14 over 64, which reduces to 7 over 32. This fraction no longer reduces, so we plug that back in for this. This is equivalent to this. 1 minus 2 times 7 over 32. So 1 minus 7 over 16. So 16 sixteenths minus 7 sixteenths. That'll be equivalent to 3 plus 6. So you have cosine of 2 theta. That's equivalent to 9 over 16. Because remember, this is all equivalent to these quotation marks. But wait a second, it's between pi over 2 and pi, which is here. So this is going to be negative 9 over 16. So almost caught myself. Almost got that wrong right there. Almost diddly darn did get it wrong. Wait, never mind, because this is times 2. So it'll be between pi and 2 pi. Wait, 2 pi, whatever, the value is this. I'm sorry. We're gonna be doing half angle identities now. Yeah, we'll do number 4, and we'll do number 6. Okay, so number 4, we have cosine of 67.5. So this times 2, because we need to find all of the theta is over 2 formulas use the value of theta. So we need to find what theta would be, because this is currently theta over 2. So this multiplied by 2 would be 130 degrees, because 120 plus 15, 135. Wait, yeah. Yeah. So theta is equivalent to 135 degrees. Now we're going to plug this into a cosine half formula. So it would be 1 plus cosine theta, or as we see over here, it's 135 over 2. And this is all in the square root. Okay, so cosine of 135. Now, if you watch my video that I just released 2 seconds ago on unit circle, you would know that 135 is a pi over 2, because 90 plus 45, so it'll be over here. So this is technically cosine of 135. If I simplify it over here, is root 2 over 2, but it's also negative. So now on the numerator, we need to simplify this. So it needs to be 2 over 2 minus root 2 over 2 all over 2. And that. So now we have 2 minus root 2 over 2 over 2. So this 2 over 2, this whole part right here, simplifies to 4. So we have 2 minus root 2 over 4, all under a radical. So the answer, you reduce this denominator, and you can't reduce this numerator, so the answer will be square root of 2 minus root 2 over 2. And it's in 67.5, so it would be in quadrant 1. It'd be in this quadrant, so it is positive. So cosine 67.5 degrees is equivalent to positive. There you go. That's how you do number 4. I'm gonna do number 6 because these are pretty easy, and then I'll do number 8 as well because these are actually pretty easy. So 6 sine of 11 pi over 12. This is equivalent to 165 degrees, because if you multiply it by 180 over pi, yeah, because it'll be 15 times 11. Yeah, so the way I did this was I did 11 over 12 times 180 pi, and these pi's cancel out. Then 12 over 18 is 15, so 11 times 15 is 165. Okay. So now we put this into the sine formula, and the sine formula is 1 minus cosine theta, or as I'm going to rewrite it, cosine of 165 all over 2. All under that. So once again, my unit circle video, this is 180, so 65. Wait a second, is that even a value? 15. Oh yeah, it's this one. It'll be 5 pi over 6, so that'll be negative root 3 over 2. You can get rid of that now. So now if we bring this over here, it'll be under the radical 1 minus root 3 over 2 minus a negative root 3 over 2 over 2. So this, let me rewrite that. That kind of looks gross. It'll be 1 minus a negative root 3 over 2 over 2. Now the minus and negative becomes a plus and positive. I always write this to keep myself in check. Then if we do this, we need to simplify these to make a common denominator. There's no common denominator here, so we need to do 2 over 2 plus root 3 over 2 all over 2. So this will simplify to 2 plus root 3 over 2 over 2. It's all in the radical still. Now remember from last time, this simplifies to 4. Then you simplify, so root 2 plus root 3 all over 2. Now, half, wait a second, that's the half angle. So the half of, so you need to multiply this by 2 to find the theta. That'd be 330. That's why I'm confusing myself. 330, whatever. Ignore that. Either way, this is what you will end up getting, and it is in the 165, so it'll be in this quadrant. So sine of 11 pi over 12 is equivalent to this. Alright? And last problem, we're going to be doing number 8. So if sine of theta is equivalent to negative 12 thirteenths, and it is in between 3 pi over 2 less than theta less than 2 pi, it says find tangent over 1/2. Find tangent theta over 2. Okay, so we're going to do the tangent over 2 formula with only sine. Is that even possible? No, we need to find cosine anyways. So this equation will look like this. Theta is between 3 pi and 2 pi, so it actually will look like this, since in between 3 pi and 2 pi is in quadrant 4. Negative 12, so negative 12 goes over here, over 13. So 13 squared minus 144, that's 25, so this side will be 5. So cosine theta will be 5 over 13. So now if we plug in the equation, tangent theta over 2 is equivalent to sine theta over 1 plus cosine. Okay. So we're going to start plugging in these values. Sine of theta is negative 12 over 13. 1 plus 5 over 13. Okay, so 13, this 1 will become 13 over 13. And you add them together. So we have negative 12 over 13 plus 18 over 13. And these double 13s cancel. So it'll be negative 12 over 18. Now I'm going to reduce this by 2, negative 6 over 9. And I'm going to reduce this by 3, negative 2 over 3. So technically this is what your answer should be. But remember, it needs to be in between half of this, half of what the original restraint would be, because theta is in between 3 over 2 and a 2 pi. It'll be over in between, theta over 2 will be in between 3 over 4 and pi, which will be quadrant 2, because pi is in here, and then 3/4 will be around here. So tangent in quadrant 2, tangent, because we're looking for tangent in quadrant 2 will be negative. So tangent of theta over 2 is equivalent to negative 2/3. That's how you do these half angle identities. Thank you guys for watching.